This is the Group 4 project by Siddharth Matthews, Madav Mathur, and Addy. And our project is based on improving bus routes. Bus transportation is very significant in part of RM's carbon footprint because, well, the gases get spent. And for this transportation, what our goal is to condense the time so that less time means less pollution. And because of that, we are going to focus on three routes: Route 4998, Route 2930, and Route 2846. And for these routes, we found a sequence of stops that allows the bus to reach Richmond Montgomery in the least amount of time and thereby decrease the bus carbon emission, which will be done by Siddharth. So our approach is very simple. It will be based on graph theory, and what this means is that the stops, which is Richmond Montgomery and the bus depot, will be treated as verticals with edges between them. These edges will be weighted with the travel times between stops. For example, like if the first stop and the second stop is 10 minutes, then the connecting stops will have the weight of 10. It's simple, just take the minute out. And the verticals of an undirected graph will be labeled. F, for example, will be called the final stop, which is Richmond Montgomery, our school. And R will represent the initial stop, which basically is the bus depot. And the bus depot for all three of these are located in 16651 Crabs Branch Way, Rockville, Maryland 20855. And all travel times will be measured in minutes. That is our standard, constant thing. So here's the data for the first route, 4998. As you can see, the largest distance is the F final, which is Richmond Montgomery, and the R is the bus depot, and 1 is Matsunga Elementary School, and 2 is Northwest High School. And for this route, there are only 3 stops: the elementary school, the high school, and Richmond Montgomery. Here's our second data, Route 2990, and as previously mentioned, the R is bus depot, the F is Richmond Montgomery High School, 1 is Darnestown Elementary School, 2 is Queen's Orchard High School, 3 is Duffy's Elementary School, and 4 is Stone Mill Elementary School. This is one of our larger routes, and will most probably have we'll able to have a shorter distance for this one. And this is our final route, Route 2846. Again, R is bus depot, F is Richmond Montgomery High School, 1 is Little Bennett Elementary School, 2 is Gibbs Elementary School, 3 is Sally Ride Elementary School, and 4 is Neilsville Middle School. So all of these three are our buses that we're going to try to condense down the time to see if we can get it in.
These are the results for Route 4998. To determine the fastest route, we used a brute force search, which means we listed every possible path from the bus depot to Richmond Montgomery. In the language of graph theory, our goal was to find the shortest Hamiltonian cycle that includes an edge from R to F. That is, we need the quickest path that begins at the bus depot R, reaches every stop, then reaches Richmond Montgomery, which is F, and then returns to the bus depot. The current route, R1 to FR, which goes from R to 1 to 2 to F to R, takes 52 minutes. Our faster route, R21FR, takes 50 minutes. The optimum sequence right now is the bus depot, then the Northwest High School, then Matsunaga ES, then Richmond Montgomery High School, then the bus depot. These are the results for Route 2990. We decided to use the nearest neighbor algorithm, or NNA, to determine the quickest route for Route 2990. I will first be giving the formal explanation for the algorithm, then I'll give a more informal one. Basically, we're going to use some mathematical notation S of x comma 1 for a vertex x is going to indicate the first sphere around vertex x. That's what it's known as in graph theory, and that basically means the set of all vertices adjacent to vertex x. Anyhow, the algorithm involves the following steps. Assume G is a simple undirected graph and let W be a weighting function that maps from the set of edges of G to the positive real numbers. The weight of the edge between vertex x and vertex y is thus W of x comma y. Alright, step 1. Begin on vertex v sub 0. This is the first current vertex. Add it to the visited set. Step 2. Let v sub n be the current vertex. Choose an unvisited vertex v sub n plus 1 that is in S of v sub n comma 1, the first sphere around v sub n, and that minimizes W of v sub n comma v sub n plus 1, that is the weight of the edge between v sub n and v sub n plus 1. This chosen vertex, v sub n plus 1, is now the current vertex. Add it to the visited set. Step 3. Repeat step 2 for all n until the algorithm terminates. The algorithm terminates when all vertices have been chosen and added to the visited set. The order in which they are added is the same as their order within the path. So, in summary, the NNA means that you begin at the bus depot, then find the closest in terms of time, in terms of minutes, the closest stop with the smallest, that's connected by an edge with minimum weight, and then you find the stop that's closest to that stop, and then you find the stop that's closest to that stop, and so on and so forth until all the stops are reached. So the current route that the county uses is R1234FR, and that requires 62 minutes of time to traverse. And the NNA returns a route that is much faster, that is faster. And this route, which we verified using brute search, is the fastest route, is R3214FR, which requires 60 minutes. And this means that the optimal sequence for a sequence of stops that visits every stop, and the last stop it visits is Richard Montgomery and then the bus depot. The optimal sequence is the bus depot, Dufeef Elementary School, Quince Orchard High School, Darnestown Elementary School, Stone Mill Elementary School, Richard Montgomery High School, and the bus depot. These are the results for route 2846. To find the quickest route that reaches every stop for route 2846, we had to alter the nearest neighbor algorithm a bit. We shall now use the notation S of x comma k to denote the set of vertices at a distance k from vertex x. And once again, I'll give a formal description of the algorithm first, and then an informal one. Alright, so let G be a simple undirected graph, and let W be a weighting function that maps from E of G to the positive real numbers. E of G is the set of edges in the graph G. The weight of the edge between vertex x and vertex y is thus W of x comma y. Step 1. Begin on vertex v sub 0. This is the first current vertex. Add it to the visited set. Let v sub n be the current vertex. Choose an unvisited vertex v sub n plus 1 in S of v sub n comma 1, the first sphere around v sub n, and then choose an unvisited vertex v sub n plus 2 in the second sphere around v sub n, such that W of v sub n comma v sub n plus 1 plus W of v sub n plus 1 comma v sub n plus 2 is minimal. That is, the total weight of the two edges is minimal. Then add v sub n plus 1, and v sub n plus 2 to the visited set, and now the current vertex is v sub n plus 2. Repeat step 3. Repeat step 2 for all n until the algorithm terminates. The algorithm terminates when all or all but one of the vertices have been added to the visited set. The order in which they are added is the same as their order in the path, and if there is one vertice left over, add that in as the last vertice. So in summary, this algorithm is like the NNA, but instead of looking at the next vertex downstream that minimizes travel time, it looks at the next two vertices downstream that minimize travel time over the two edges that connect them. So imagine taking the entire path and splitting it up into two pairs of edges that share a vertex. And that's basically what this algorithm aims to minimize. It aims to minimize the total weight across those two edges in the whole path. And the current route used by the county for Route 2846 is R1234FR, which again means that the path begins at the bus depot R, and then goes to stop 1, and then stop 2, and then stop 3, and then stop 4, and then F, Richard Montgomery, and then the bus depot again. This route requires 60 minutes. Our algorithm produces the faster route, R1342FR, and which we have verified again through brute force search that this is the fastest route, and our route requires only 59 minutes. And this means that the optimum sequence is as follows: the bus depot, Little Bennett Elementary School, Sally Ride Elementary School, Neilsville Middle School, Gibbs Elementary School, Richard Montgomery High School, and the bus depot.
Finally, it must be asked, what significance does this have to Earth as a whole? While the impact of just a few bus routes in Montgomery County may not be as wide as you may think, if this is spread on a much larger scale, the environmental impact could be massive. Overall, with 2 minutes saved on Route 4998, 2 minutes saved on Route 2990, and 1 minute saved on Route 2846, a total of 5 minutes has been saved per day. In order to estimate the amount of fuel saved, assume an average speed of 50 miles per hour. The approximate distance saved is 5/60th of an hour times 50 miles per hour, or 4.17 miles. Since each bus has a mileage of 7 miles per gallon, we divide 4.17 by 7 to obtain 0.6 gallons of fuel saved per day. This translates to 180 times 0.6, assuming approximately 180 days of instruction, or 107 gallons of gasoline saved. According to the Environmental Protection Agency, 107 gallons of gasoline translates to 0.951 metric tons of carbon saved. The improved bus routes do indeed reduce Richard Montgomery's carbon footprint. If our methods were applied in order to optimize all Richard Montgomery bus routes and all bus routes in MCPS, the carbon footprint of RM and MCPS could be dramatically reduced. Decreasing one's carbon footprint has enormous implications for biological systems worldwide. Reducing carbon emissions helps to combat global warming, which threatens many ecosystems on Earth, including those containing animals living in the Arctic, such as the Arctic fox and polar bear, and on coasts. Global warming also threatens organisms due to factors such as ocean acidification, which affects dissolved oxygen levels in the ocean, changing currents, and thermohaline circulation, and more volatile weather systems. So, as you can see, the overall impact of changing the bus routes in MCPS will have much larger overall implications than one may think, and a large impact on global biology and ecology today.